Awesome. So I talked about strings yesterday and how we can get at different parts of strings with indexes. So we got at the letter P in Python using the square brackets and putting a 0 in there. And I mentioned that perhaps it's good to think about strings a bit like lists. They're lists of letters to some extent. Well, we're going to introduce real lists now, and a lot of what we learned before is going to apply here. So to define a list, a bit like defining any other variable, you put the variable name on the left of the equal sign, and then the values you want it to have on the right. For a list, we put these square brackets around it. So this defines an empty list, which I'm calling my list, and it's going to have no elements in it. If I want to define a list with some things in it, I separate those elements with a comma. So if I define a list called my shopping list and set it equal to the string apples, the string beer, and the strings chocolate, then we have those three elements within that list. I can check the values that are in the list by typing the name of the list, just like I do with any other variable. You can check the value of a variable by typing its name and hitting enter. So what's in my shopping list? Well, it's the same three things we put in. Now, if you've programmed in some other languages before, you might be used to lists having a type. So it might be a list of numbers or it might be a list of words. In Python, you can have different data types within a single list. So a list can have mixed data types. So here I define a mixed list, and it contains some numbers, some words or a string, a float, an integer. So you can have lots of different data types all within one list. And all you have to do is enclose them in square brackets and separate them by a comma. Okay, so once we have our data in the list, the way we access the data in the list is kind of the way you might expect and the way we introduced when we were talking about strings. So here I have a list of nucleotides. It contains 4 letters. And to get the second element, I do my nuc list, and then in square brackets I put the number 2. Now be aware that we start counting at 0. So the element at index 0 is A, at 1 is G, and 2 is C. So when I do my nuc list 2, the letter I get back is the C that's in index number 2. If I want to update the letter that's at that index, that's at index number 2, I can do my nuc list 2 equals, and then in quotes put the new string that I want to put into that index. So we update individual elements within a list by referring to them by index on the left of an equal sign, and then on the right of the equal sign giving the new value we want that element to have. So after we've updated the second element to a G, we can check what value the second element has by typing my nuc list and then in square brackets putting the number 2. And we see that it does indeed now contain a G. The last time we ran that line it contained a C, so we've definitely updated the value. And if we check the total nuc list contents by typing my nuc list, we see that it's now AGGT rather than AGCT. So this is very much like strings. We start counting at 0, we refer to them by index, but you can update individual elements using this, this index notation like this. So once we have our data in the list, there's a bunch of handy things we can do with them. If you want to add another element onto the end of the list, it's very common, you're looping through your data, you're doing some processing and you're adding a new value onto the end of a list that is your output list. You can use .append. So if I start with my nuc list is AGCT, and then I .append a C, I then check the data that's in my nuc list and I see that it's AGCTC. So I've got this extra C at the end because I just used .append. I can use len, just like we did with strings, to check how long a list is. So if I do len of my nuc list, I see that it's now 5 elements. It was 4, but we appended one, so it's now 5. .index will tell us the index that a element first occurs within the list. So I want to know where G first occurs in my list. I do my nuc list .index and then a G, and I see that it's not at index 0 because that's an A, but it is at index 1 because that's the G. My nuc list.index C has a value of 2 because it's not at index 0 or 1, but it is at index 2. So it's not A, it's not G, it's the C. So it's found at index 2. Be aware that if you try and do .index for an element that's not in the list, you'll get this value error back. So if we're using .index to find out whether something is in a list, we're going to need to learn to handle these error messages and what to do with them, and we'll come across that towards the end of today. Everyone follow how we are getting different parts of a list and updating values? Okay, so there's also some other handy methods like sort. If we have a list of nucleotides that are not in alphabetical order, we can use .sort, and Python will attempt to sort them. Obviously, this depends very much on the data type that's in your list. If it's numbers, it will put them in numerical order. If it's letters, it will put them in alphabetical order. If you have a mixed data type, it might struggle, you might get an error, or it might sort them into an unexpected order. So this is only really good if you have a sort of common sense list of things that you might expect that are sort of obvious to sort. But if we do mynucleus.sort, this takes no arguments, so we just have two empty brackets at the end. We find that it has now reordered our list into alphabetical order. We can use .remove to remove a specific element from the list. So rather than doing .index to find it and then deleting the specific element from the list, we can actually just do .remove, which will find the first occurrence of it and take it out of the list. So if my nuke list is this sorted list here, and then we do .remove G, we find that the G has gone and we're left with the rest of the list as it was in the same order, but the G is no longer in the list. So .remove will take away the first occurrence of an element in a list. Alternatively, if you want to remove a specific element of the list using its index, you can use del. This del keyword allows you to delete specific elements by index. So if I do del, my nuke list index 1, it will delete the element at index number 1. So this is my nuke list before we run del. Then we del my nuke list 1, and the element at index 1, remember we start counting at 0, so this 1 is this A, gets removed, and we're left with the rest of the list with that A deleted. So you can use .remove to sort of search for an element and remove it, or del to remove it by the index, the number that is stored in the list. Does that make sense to everybody? Awesome. Okay, so similarly to strings, we can get parts of a list. We can slice out little parts of a list using this colon notation. So if I have a list of letters, A to F, if I do letters 0, 2, it will get all of the letters from index 0 up to, but not including index 2. Remember, whenever you have an index, colon, another index, it includes the first index, and then it goes up to, but does not include the second index. So letters 0, 2 will get the element at index 0, the element at index 1, but not the element at index 2, and so we get AB back. Now, some of the numbers on either side of this colon are optional. If you don't specify them, Python will figure out what's going on and go from the beginning or the end of the list as is appropriate. So if you do letters with no number there and then a colon 4, it will know to go from the beginning of the list up to, but not including index 4. And so we get the beginning up to, but not including index 4. Remember, because we can't start counting at 0, that index 4 is going to be 0, 1, 2, 3, 4. It's going to be this E, so we don't get that E. If you do an index colon and then nothing, it will know to go from that index up to the end of the list. So if we do letters from index 1, colon, no argument, it will go all the way from the index 1, which is B, all the way to the end of the list. One trick to be aware of is if you try and get an element beyond the length of the list, so if you do 6 in this list that has the last index at index 5, 0, 1, 2, 3, 4, 5. So if you try and get an index 6, you get this index out of range error, which is very similar to what happened with strings. But if you try to slice out part of the list, it doesn't matter. If all of these indexes are out of range, you don't get an error back, you just get an empty list back. So it's something to be aware of. Don't rely on an error to figure out whether your list has things in it. Because you can slice out parts of a list, you'll get an empty list back, but you won't necessarily see an error. So it's important to be aware of the fact that when you're using this colon notation, just because there's no error thrown doesn't mean you've successfully got numbers back from your list. You may have just got this empty list back. So you'll then need to write another line to check what's in the list. Everyone follow what's going on here and how we're picking out bits of the list? Awesome, okay. So lists are great. Lists are particularly useful for data that is ordered. So you might have a time series. from your experiment. You might have some dilution series. Anything that's in an order that needs to be maintained, we would store in a list. However, dictionaries are useful for data that is not ordered, but is referenced by some key. So for example, if you have two conditions, you have a wild type and a treated condition, or two genotypes, or you have different stimulus, you might have LPS and CPG or something, and you're referring to these data points using a key, a name, then that's where dictionaries come in. So dictionaries are not ordered. The order that things are stored in the dictionary is arbitrary, and you can't sort them or reference them in any order. However, you can reference them by a key. So let's see what that means. Everything in a dictionary is a key and value pair. So it's very much like a list, except that each element is not just a single thing, it's a pair of things. It's a key and it's a value. So here I'm defining a dictionary called experiments, and it contains three different key and value pairs. The key control has the value 1000. The key exp1 has the value 500, and the key exp2 has the value 600. So I have this three-element dictionary. You'll notice the other difference is the syntax for a dictionary requires these curly braces rather than the square brackets that we use for a list. Now these keys are usually strings because you're usually referring to it by some experiment name or some condition name. They can be numbers as well, but if you're referring to them by numbers, you may as well be using a list because you probably have some ordered data that you can store using the list indexes. The values can be almost anything. They can be other lists, they can be other dictionaries, so they're great for storing any data you want as long as you want to reference it with a key. So if I check the value of my experiments dictionary after I've defined it, I can see that it contains everything we put in. Note that the order that it's coming back in is not necessarily the order we put it in. The order is not maintained, that you can't guarantee the order of a dictionary, but it does contain every key and value pair that we put in there. So if you want the value that corresponds to a key in a dictionary, use the same sort of square bracket notation we used for the list, but rather than giving the index as a number, we give the key that we want to get the value for. So if I want the value associated with the key exp2, I write the name of my dictionary, experiments, and then in square brackets I put the key. And the key is exp2, and what I get back is the value 600, because Python goes to the dictionary, finds the key exp2, and returns the value associated with it, which is 600. So if I want the value associated with the key control, I put control in the square brackets and I get the value 1000 back. You can add or update values in a dictionary just in the way you might expect. You do experiments, and then I might define a new key, exp3, and I'm going to put that on the left of an equal sign, and on the right the new value I want that to have. So I want the key exp3 to have the value 300. Now when I check what's in my experiment dictionary, it's all of the three experiments and the control. Remember, the order is arbitrary. So we have control, exp1, exp2, and exp3 all in our dictionary, and it's added exp3 using this line. You can remove individual items from the dictionary using the del keyword that we just used for lists. So if I want to delete the experiment 2 from my dictionary, I do del, experiments, and then in square brackets the key that I want to delete. And then if I check what's in my dictionary by typing its name and hitting enter, I can see that I have the control in experiment 1, experiment 3, but experiment 2 has been deleted. Does that make sense? Everyone with me? Awesome.